Hello everyone and welcome to Tech with Robert, the Get Started with T-SQL course. In this lecture we're going to talk about numeric values and how we can work with them in T-SQL. But before we get started, don't forget to subscribe to my channel, give a thumbs up on the video if you like what I do. That really helps me to know what I do well and what you guys want me to improve or focus more on in the future lectures. Without further ado, let's dive right in. So when working with T-SQL, we have different types of numeric data types. So these are categorized into exact numerics and approximate numerics. And so if we start off with the exact numerics, we have four different data types that we're going to look at. And let me just start off by creating a variable here called my tiny int. It's going to be a tiny int. So that is the first exact numeric data type. And if we say that we set that to 255. So I'm going to make a comment here and we're going to say the maximum value here it stores is 255 and it uses 1 byte. So what this means is that we can store the maximum numeric value that we can store in a tiny int variable is 255. So if we see here, if we select my tiny int here, we see that we get 255. And what if we change this so we say 256? So now when we try to run this, we see that we get an arithmetic overflow error for the data type tiny int, the value 256. Because the maximum value that we can store in a tiny int, the data type variable, is 255. And so the second numeric value that we have here is a small int. So we could say small int, it's a small int. I will set that to 100, for example. If we select this one here, we see that for the small int, we can store from minus, let me just type it out here, we could say in here, we can store from minus 32,768 to 32,678, and this one stores 2 bytes. So we can store values from between this range over here. The third one I'm going to talk about is, and this is the most commonly used one, it's just a regular integer. So we can type in my int and we say that it's an integer. I will set that to 10. So the regular int here is basically saying, all of these numeric data types, we are specifying that the value in this variable is of a numeric data type. So we store numbers here, and more specifically here, exact numbers in these three different types of data types. And this one is, let me just here, the integer stores values from, let's say for this value here until to the positive one, so from negative here to, and it stores 4 bytes. And then lastly, we have another variable that is called a big int. And we can set that to like this, for example. So as you may notice here, what I did here is I specify them from the smallest to the largest, and this one is quite a large one, and it stores 8 bytes like this. So the difference here is mainly how much space we need to allocate in order to use these different types of data types. And the most commonly used one is integer, but there are some scenarios where you need to take a closer look at this and how you can optimize the queries and the data types. Because let's say, for example, you have an application, and in that application you type in a number between 0 and 10, 100 for example, and that numeric value is used to represent some kind of percentage, you know, like 25 or 79, 69 or whatever. And if there's a rule in this source system where they enforce that rule that you cannot specify a number larger than 100, so you can only select a number between 0 and 100, you could, for example, use a tiny int to store only 1 byte here. But what if you run some queries in your database and you see that, almost all of the numbers here, the majority of numbers here that you see are, they are 100 or less, but so could I use a tiny int? You could, but there is a risk. So if you cannot guarantee, like if there aren't any rules that enforce the values between 0 and 100, you could have a risk with, for example, somebody typing 1000 or something by mistake. They were going to type 100, but they typed 1000, for example. And if there aren't any rules to enforce that they cannot enter 1000 there and save it, then I would prefer to use an integer instead. But as I mentioned, it's the same with when we were looking at the previous video, when we looked at working with strings. It's the same with using a char or a varchar. So we had, for example, for a gender, we had male or female. So if we can guarantee that there's either an F or M, we could use a char. Otherwise, we use a varchar. And so it's the same logic here. And the main difference between these is just, the range from the type of numbers, the range of numbers that you can store in each variable type here, and how many bytes you need to allocate in order to use that data type. So these are the exact numerics, when you work with exact numbers. There's another data type called float. And so watch what happens here is, if we declare, we can say my num1 here, we say that as an integer, and we say that it's going to be 10. And then we have another number here, my num2, and we also set that to an integer, and we can do this like this. First we say, okay, we're going to select my num1, and we see the number 10. And then we could do some mathematics on that number. So we could say my num1 plus 10, or we could say my num1 minus 5, and we could do my num1 times 2, and we say my num1 divided by, let's say, 4. So if we run this, we see that, okay, we have the number of 10, we add 10 to it and we get 20, we subtract 5 and we get 5, and then we multiply by 2, we get 20. And when we divide it by 4, we see that we get 2. So we get the exact number, but we don't get any decimals here. But so 10 divided by 4 is not 2, it's 2.5. So how can we solve this? There's another data type here called float. So if we declare, for example, here we declare my num2, and we set it to float, and we say that that is number 4. We can now, in the division here, we can divide the first number with the second number here. Or actually, let me just type the first one here as well, so we can see this. So if we run this query, we see that we get 2.5. And so this float variable here is for using approximate data types. Approximate numerics. So here we get the correct answer, we get 2.5. And the thing here is that if you notice that only one, we could also change this one to number 10. And you see all of these will still work here. So the thing that you need to remember here is that if one, let's say you have two numbers like we have here, and if one of them are of the type float, the result is going to be a float number. So it doesn't matter if this one is an integer and this one is a float, the result is going to be a float as we saw here. And the same, and it doesn't matter which one is an integer, which one is a float. So we could say that this one is a float and the number we're dividing with is just an integer, and we will get the same result. We will still get 2.5. So as soon as one of the numbers are a float, we will get the result as a float. We have a couple of more data types that are from, how do you say, some are approximate values, right? And these are decimal and numeric. And so if we start with decimal, we could say, we could declare a here, and we could say as a decimal, and we need to provide the scale and precision. So we can say, for example, 5 and 3. And if we set that to, let's say, 1.41 or 30 or 41 here, notice what happens when we select this variable here. We see that we got 1.41 and 0 here, but we only specified, we said 1.48, 41. Why do we get 41, 0? It's because the precision here is we're getting 3 decimal points here. And so if we say 5, for example, we would just get 2 extra. Oh, sorry. If we write it like this, then we get 4 decimal. The problem there was that this one here has to be lower than this one over here, the first parameter. That's why we got the overflow error. But so we see here that no matter if we just type 1.4, we have still specified that we want 4 decimal numbers. So we will still get 1.4, but then with 3 zeros. So we have 4 decimals here. And we also have another type here called numeric. So if we declare another one here, and we say B, we say numeric, let's say 10 and 5, and we say that to 34, 5, like this, and we select B as well. We see the same thing here. We will get 5 decimal values here. And the numeric and decimal data types are very, very similar. I mean, I'm not going to go into greater detail on what there are some small differences, but they're very, very similar. They're more similar than they are different. So we could say that, the numeric one is a strict one. It enforces the exact position and scale that we have specified here. And whereas the decimal allows more numbers than the stated precision. I'm going to leave a link in the description if you want to read more about these. As I said, it's out of the scope for this tutorial. I just sort of wanted to show you that there are different types of numeric data types that we can work with in T-SQL. And so in the next lecture, we're going to talk about how we can work with dates and date times. So I will see you guys in the next lecture.